Now we are going to start up with current. See, we have two types of currents. One is the electric current, other is the conventional current. One is the electric current, other is the conventional current. Like when the science was, when we were lacking in the scientific knowledge in the earlier times I am talking about. So at that time people used to consider that the current which we are actually using is the conventional current. But nowadays, as we all are aware of the facts around, so we know that the current which is of practical use or which we are using or which we are getting at home is an electric current. So what is the difference between the two we are going to study here? Electric current is the rate of flow of electrons. So in it the electrons actually flow, and in conventional current it is rate of flow of protons. It is rate of flow of protons. This current flows from a negative terminal to a positive terminal, and this current flows from positive terminal to a negative terminal. This is practically important, this is not practically important. But if we talk about, like if we connect a battery, we say that conventionally the current is flowing from positive to negative in external circuit. But when we talk about internal circuit, the current is flowing from negative to the positive terminal. So this is what is a electric current. So as I told you, this is of practical importance, we are going to consider this one only. So we say that it is rate of flow of electrons. We can also replace the term electrons with the electric charge, one and the same thing. Right. So this is the electric current. How we go to denote that? It is I is equal to Q upon T. Rate means divided by time, flow of charge means I is equal to Q upon T. And if we look for the SI units, SI unit of current is ampere. 1 ampere is equal to 1 coulomb over 1 second, as the unit for the charge is coulomb and time is the second. So how we are going to define? Again, don't cram the definition, you can just make the definition yourself. Left hand side I told you that we write this said to be this. So that means current is said to be 1 ampere when 1 coulomb of current, obviously current flows. So when 1 coulomb of current flows through wire in 1 second. When current flows, 1 coulomb of current flows through a wire in 1 second. So this is how you define. Current is said to be 1 ampere when 1 coulomb of current flows through a wire in 1 second. And the instrument which is actually used to measure current, that is none other than ammeter. It is ammeter. This is generally used to measure current. But if we wish to measure very small current, very small, or like induced current, so there we don't use ammeter. Instead of that we use galvanometer. So galvanometer is an instrument again used to measure current, but very small current. But generally in circuit we will be using the ammeter. How we use the ammeter? What symbol is being used? Ammeter is this and galvanometer is this. This is how they are represented in a circuit. And how you connect the ammeter? As I told you, voltmeter is connected in parallel combination, ammeter is connected in a series combination. And why or what is the series or parallel we will be discussing when we will discuss these circuits. So for now it is sufficient till here that current is the rate of flow of electrons or electric charge. I is equal to Q upon T. In terms of units, 1 ampere is equal to 1 coulomb over 1 second, and current is said to be 1 ampere when 1 coulomb of charge flows through a wire in 1 second. So this is what is an electric current. Now there is a law formulated by a famous scientist, that is the Ohm's law. That is the Ohm's law. Now what does this law actually states? Before we go on to this law, I want to tell you that like I explained you that there is one body A and there is one body B. I told you there it has many number of electrons, it has comparatively less, and the charge is flowing from A to B. So if I want that the charge should continuously flow, then what I need to have? Obviously I need to have a difference in the number of electrons, and what's that? That is the potential difference. So that means if we want a continuous current continuous flow of current, what we need to have? We need to have potential difference between 2 points. And how we create permanent potential difference between 2 points? By introducing a battery or cell in a circuit. As I told you, battery is denoted by this, right? So, by this or by using a cell, because it contains two terminals, one is at high potential and other is at low potential, and never they are going to be at the same potential. So, introducing a battery or a cell just confirms the continuous flow of current, because there will always exist a potential difference, and that is must to have a continuous flow of current. So, this is what is this electric current and the instrument and the 1 ampere, and how we can have the continuous flow of current. We will be taking the Ohm's law in the next slide. So, just look at the board carefully.